higher, and the water potential forces the water in. If you put them in higher concentration, 0.4, 0.6, 0.8, and 1.0, they lose mass and they lose more and more and more as you get higher in the concentrations. Okay, so that's going to end up making that graph that looks like this. Actually, let's get rid of this stuff here. And I think we went over that last time already, so you don't really, I don't need to go into this in great detail, but the graph looks like this. All right, and we look for this spot right here to see what the concentration inside of the cell is, and that allows us then to figure out solute potential inside of the cell. Whether it's an egg, whether it's a plant cell, I don't really care. That's what that's all about. Okay, everybody good on that? Spent quite a bit of time last time talking about that, so I'm going to keep moving. The new diffusion lab that the College Board implemented a few years ago, that they're suggesting you do, to me is a lot stupider. I don't like it that much. It is very simplistic, and it really doesn't teach those solute potential and water potential concepts very well at all. It doesn't really address them at all. It deals more with surface area to volume ratio, the stuff that we just talked about. So you're supposed to simulate cells by using agar cubes, like gel. It's like Jell-O, basically, cubes. And if you do a big one, it has a low surface area to volume ratio. And if you make a small one, it has a high surface area to volume ratio. That's what you're supposed to discover. So we soak these cubes in phenolphthalein, and then they have like acid in them or something like that, so it changes color. It's the same. You guys do titration in chem?
No.
You do pH already?
No.
But you guys are missing out with COVID, man. COVID really screwed you over in chem.
Yeah.
What are you guys on right now?
We're just
The
starting
dinosaur.
yeah, the
H2O.
Triceratops?
Psycho.
Stoichiometry?
Yeah.
Stoichiometry, wow. Okay, anyway, so phenolphthalein is just the thing that turns pink when the pH goes to about 8 or something like that. So as this thing is absorbing more base, it's going to turn purple. Where the pH is low in the middle, it's going to stay white, and as it's absorbing more and more, the more it's diffusing in, the more purple it gets. So you leave it in for 5 minutes, whatever, the small cube is completely purple throughout. The phenolphthalein diffused all the way through into the middle in 5 minutes. In a large cube, the phenolphthalein only diffused this far, and the entire inside is still white, which means the diffusion takes way, way, way longer in a large cell than it does in a small cell, which means the middle of the cell would never get the necessary nutrients and oxygen and stuff like that. And that's the reason why living organisms have tiny cells, not big cells. So even elephant and whales and dinosaurs, Triceratops and stoichiometry and all that stuff have small cells because even large animals have small cells because the cells require nutrients and oxygen, and diffusion would just take too long. It's too inefficient because of that terrible surface area to volume ratio in a large cell. Elephants and triceratopses and whales just have more cells to make them big, not bigger cells. Is that clear? All right, so that's what that diffusion lab is supposed to show you. I don't like it as much. I don't think it's worth doing because you can just talk about it for like 10 seconds and get the same benefit out of it. I think the one that we do is way better because it lets you do water potential stuff and it's more high-end. So, all right, enzyme catalysis. So normally what we would do is catalase. And I like this lab, even though you didn't get to do it, sorry, because of COVID, because it has a somewhat complex protocol, and it's pretty challenging in terms of the thought process of how this works. Okay, so the idea is this, that hydrogen peroxide breaks down into water and oxygen. All right, and in our lab, in the pivot one, it was super easy. We just collected the oxygen gas in a test tube, and we measured it with a ruler, and we just said, you know, it's 8.7, done. That's it. And then we know how much oxygen was produced. There was like no skill to it. It was super easy, just measuring with a ruler. So catalase does this, the enzyme catalyzes this reaction. So that's the enzyme we're going to use in this. In the actual lab that we would have done, like the wet lab, if we would have been in person, what we did instead is we measured See, it's hard to measure this unless you have a setup like this, and this is complicated because it becomes pressurized, so the volume isn't actually very precise. It's not really that good of a way to measure. And measuring water is not easy either. That's tough to do. So what we did instead is we measured how much of this was remaining. So let's say I start with 10 mLs of H2O2. Okay, and then at the end I have 9.8 mLs H2O2 remaining. So if I have 9.8, and then in another experiment I start with 10, and then I have 2.3 mLs remaining. Okay, so here's two numbers, 9.8 and 2.3. Which one shows a higher enzyme activity? So thank you, that's the right answer. Some people are going to go, oh, 9.8 is higher, so therefore that has a higher enzyme activity. What you're forgetting about is that how much enzyme activity was there in the first one? How much was broken down? 0.2. 0.2 mLs were broken down, that's it. That means very little enzyme. Can we get to the point where if I do this, you say little? If I go like this, if I go like this, it's big. Can we just agree? We only got like one more class left, and it took this long. I'm still not happy there, but like, if on Tuesday you could do this, I feel like I would have accomplished something. Maybe you learned no biology, but at least now you know what big and small is.
Wait, so what are we doing after the test then? What are we like?
Let's not worry about that right now. Right now, I'm very anxious about getting everything covered.
I guess.
What happens after will be a mystery to you.
Party
It'll be a mystery. It'll either be the best thing that ever happened to you, or it'll be the worst thing.
How many people have like failed the test that you know of?
What?
Like how many people have failed?
Failed?
Like the AP Bio test?
Like passed?
Yeah.
What, you mean like 2 or a 1?
Yeah.
That you consider that failing if you have less than 3?
Well, I mean, isn't
Well,
that
last year I had 2
that
out
was
of
it?
like 17.
15
15 got 3 and higher, but that was one of the better ones.
So
Usually I'll have like, let's say I have 20 kids taking it, I'll usually have like 6 kids that don't.
So what are my chances?
Your chances are good.
What? How?
I predicted 3 for you.
When do we get our scores?
July,
Interesting.
generates in July. With COVID, they'll probably like take longer. They'll say, because of COVID.
Okay.
You know what I mean? but usually July.
Okay.
If we get a 5, can we get a present, like candy?
No. If you get a 5, I will take you out for lunch. I'll pay for it. You
Actually,
pick the place.
Imagine I
Whoever
got
gets
a
a 5,
5.
I'll take you to lunch. I'll make you a better deal even. If every single person that takes the test gets a 3 or higher, I'll take the entire class out.
What's up with you and
Well,
paying for
and
it?
I'm talking about like a fancy, high-class restaurant like Olive Garden.
I can
Outback.
actually study now.
I want an Outback.
Olive Garden's too expensive, I can't afford it.
I'll show you. I'll actually
But if we go to Olive Garden, we're gonna order one order of all-you-can-eat breadsticks, and I'll share that one all-you-can-eat.
That sounds good. Yeah.
Next time we won't have to sit in the car. We'll just have a runner going back and forth. I don't think we have to worry about that quite yet. Let's worry about it once everybody passes. How about that? Okay. And also, there are some people signed up to take the test that maybe shouldn't be. Some of them not here right now. Some of them not here right now. I'm not talking about you, so stop. But you might want to consider getting your money back and not take it, and that's just something to think about. Then there's also a bunch of people who are not taking that definitely should be taking it. Ryan. Excuse me?
Not about me.
You?
No, I'll probably block
You?
if you do that.
You're taking it. You're taking it, right?
I'm taking it.
You are?
Well, like this is where he's a coward.
You paid, you getting your money back? Did you pay and you're gonna get your money back?
Oh, it's free for me, but I'm not
How is it?
It's free, then take it.
Because, Elena, we're poor.
Take it.
How is it free for all of you guys?
I don't know.
Take it.
I paid for it. How do you get it for free?
That's complicated, I don't know how that works out.
I actually paid for it initially, and then they gave it back, my money back, but I still did it.
Anyway,
Because he's a minority.
Stop letting me go to my driver's ed.
All right, cool. So that's the enzyme lab. So then you have to like do some mathematical gymnastics to get this into a meaningful value that actually makes sense in terms of enzyme activity. Because obviously if you graph this, you said 9.8 and over here you said 2.3, it would look like this as the higher rate. So you got to convert that and make that more reasonable. All right, all the enzyme stuff we already talked about, so I don't have to go into that again. Why it levels out, all of that stuff you should know. All right, oh, mitosis, basically that's the freshman lab that we do freshman year where you look at onion root tip cells and then you count how many there are. Oh, there's 7 prophases, there's 15 metaphases, there's 500 cells total. We just figure out, 17 prophases divided by 500 times 100 is, whatever the frequency is. But what you can do too is, let's say you get 17 out of 100 prophases. I'm just making up numbers. That's 0.17, right? That means 17% of them are prophase. That means prophase lasts a certain amount of time. If you know that a cell cycle for, or if you know that one cycle for these cells, for these onion root tip cells is, let's say, 24 hours, what you can do is you take 0.17 times 24, and that'll tell you how many minutes prophase lasts, or how many hours prophase lasts. Are you with me? You can actually calculate the time. Because the longer the stage lasts, the more cells you're going to see under the microscope. Does that make sense? I like how this guy's nodding. He's the only one nodding, but at least somebody is. Oh, up here.
Go home.
Please take 10 minutes. 10-minute conversation.
I should have done. Right.
So short. See, you gotta do the small talk.
How's your day going?
Were you able to hear that when I picked it up, they were yelling?
No.
Like right when I was picking it up, there was already yelling going on into my ear. Like, what? I didn't do anything yet. Like, why are you yelling at me
I
already?
didn't do anything yet.
Do you ever have that happen? People call you and they're talking before you even pick it up?
Yeah.
It's like, what the crap?
No.
No one calls me.
No one calls me.
Alright. Okay, so that's that. That's pretty easy, straightforward. You should probably know what happens at the stages of mitosis. Like you should understand mitosis, meiosis, all that stuff. There's a lab that I used to do with the kids that never worked. It never worked, and that is this lab right here. This is dealing with a fungus called sordaria. And fungi are really weird, their reproduction is really weird, and their cell divisions are weird. They actually have mitosis happening with haploid cells, which is odd. Like if you eat a mushroom, like on pizza or something like that, like mushrooms, the things that come up out of it's called a basidiocarp in science terms, that's haploid cells, not diploid. So their body structure is haploid, it's bizarre. We're used to everything being diploid, you know what I mean, and just the sperm and eggs being haploid, so for fungi that's how it is. So it makes these spore cases that they're called asci, and the little things are called ascospores. And the way that they are set up is like this. If you have, basically what you do is you take a fungus that's dark brown and a fungus that's white, and you cross them so that in the middle they form hybrids. They form like the combinations of the two. So eventually what happens is, after meiosis, you're supposed to get 4 cells, just like with humans. We get 4 sperm or like 3 polar bodies, 1 egg, 2 divisions, 4 cells. Well, they have 4 cells too. What happens is, in this spore case, this ascus, they call it, it's kind of an odd word, mitosis happens, and they divide again to form 8 cells. So it's mitosis of these haploid cells, so that's going to form this. So 4 of them are going to be black, 4 of them are going to be white. If that happens, then no crossing over has happened. So if you see this, no crossing over happened. If crossing over happened, they're going to look like this instead. You're going to see 2, and then 2 white, and then 2 black again, and then 2 white. Or you're going to see this. Thank you. guys. You laughing at them or at me? I'm very insecure, so I never know what's going on. Okay, so you gotta see this. That means these guys are crossing over, these guys are not crossing over. All right, so you count all of your ASCII, and you can then calculate the distance of that gene from the centromere. So this is similar to doing a map distance calculation where you're calculating how far apart two genes are, but we're only looking at one gene here. We're only looking at the color gene, and you can figure out how far from the centromere the color gene is by just adding up all the crossing over recombinant events divided by the total. Very similar to that other calculation. So that never worked, it's a big pain, and I stopped doing it, and I just give the kids like stuff to count. So if you actually wanted to practice this, you could look at this picture and you could count all the ones that are recombinant, where they have the 2, 2, 2, 2, or the 2, 4, 2. Like here's one, 2 black, 2 white, 2 black.
Wave 1 is dismissed. Wave 1 is dismissed.
Here's one that's not crossing over, so it's not, there's 4 black and then 4 white. You with me? Here's a nice one, there's 2 black, 4 white, 2 black. You count all of the recombinant ones divided by the total. You don't count the ones that are all white. You don't count the ones that are all black. They're not a cross between the two color variants. You just skip those. But that's sordaria. It's very unlikely to be on the test. Just in case, I just throw it up there just in case. So, by the way, just be ready that on this test you're going to see things that are new. I've said this before many times, but I'll say it again. You're going to see things that are unfamiliar, and you're going to go like, oh, that's not fair. No, it's like that for everybody. Everybody that takes these tests it's going to come into things that are like brand new. And they love giving you like complicated like gene names or plasmid XQ alpha 3. And you'll be like, what the heck is it? It's just a name. Who cares? Forget it. The concept is going to be much simpler than it at first looks. They'll give you this big paragraph with all this complicated names and stuff, and you're going to be intimidated, and then you're going to remember, wait, Volk said it's okay, I can do this, and then you'll really be like, oh, I know this. That's not so bad. What?
So for the, you know how you had that one type problem with like ethics?
Yeah.
So is that exactly how like a regular FRQ would look like?
Yeah, that's from the color code.
Okay.
That's what it would look like. By the way, their diagrams they give you are horrible. Whatever diagrams they give you, like a cell picture or some kind of mechanism or whatever, it's going to be like 10 times worse than anything I've ever given you, and it's always going to be a pain. So you just got to get over that too and just accept it and go, oh, this is just a, may I say a bad word?
Yeah.
This is just a shitty diagram. I actually understand what this is. This is fine. Oh yeah, don't record that.
Yeah, I mean, it's too late now.
I said shippy, like from a ship.
Just delete it so you don't have it on his phone.
Hey, keep the part with Ensign though.
All right, how much time we have?
A minute.
We're on wave 1 right now?
Yeah, it should be wave 2, but I think he forgot.
Wave 2 is, oh yeah,
So he's laughing at herself.
They're having.
we're just going to be stuck here the whole day because the thing's broken.
Wave 2 is dismissed.
No, that's what
Wave
it
2.
says. Okay. Photosynthesis. Did we do photosynthesis? Did I already do one? Yeah. This lab, the photosynthesis lab, is one of my most favorite labs. The kids love it. They did a web stream, like a live stream last year. Couldn't do it this year because we stupid COVID. We did the pivot. It was kind of boring. The leaf disc assay is super fun. We try different colored lights and stuff like that. There's another one that's DPIP. I might have talked to you on Zoom about DPIP and how that works. I don't know if I did. She says yes, he says yes. Well, you say yes to everything now. I don't know. I do appreciate your nodding though, I gotta tell you. It really helps me because everybody else is like, you're like with me, and like that's, has any teacher ever told you that's appreciated?
No.
No? Well, in college, keep doing that. Because the professors will appreciate it. Because most of the kids in college are going to be like this. So, anyway.
Go to like in college, like those big classrooms where we sit all the way up in the back.
I know, I would say
Well,
at the top.
that depends on where you go and it depends on the class. My son has been in classes, and my daughters too have been in classes with 200 people, 300 people or whatever. I've been in a class with 500. Freshman history at Marquette was 500, 600 people or whatever, in a big auditorium. My son was in a class with 4 kids and the professor. 4 students and a professor. It was his advanced German class, and it was just 4 students just sitting around or whatever. So when you have a class like that, walking in late is noticed. Falling asleep is noticed. You know what I mean? You can't get
They
away with
don't
it.
care about attendance, dude.
A lot of them do.
Do they?
Yeah, a lot of them do.
My brother told me they don't give
But it
crap.
depends, once again, depends.
Like those classes are usually like.
That guy, the guy that I had for that class was mean though. Like if he came in late, he would call you out.
Like you couldn't even.
He would like call you out and he would like embarrass you in front of 500 people.
What? I'd be like, yo, what's up?
Were you ever called out?
Huh?
Were you ever called out?
No, of course, that was perfect. No, let me tell you another one.
Three is dismissed.
Real quick, 10-second
Three.
story. Organic chem, I had 220 people. On the day of the final, some kids had other people have take the test for them. Because they didn't know any stuff, so they hired somebody to come in and take the test for them. The professor stood in the front and goes like this. And he had the TAs go up to the guy and check ID, and he knew exactly who wasn't supposed to be there. And those people failed. We were freaking out, it was great. I of course did not do that.